All right, guys, so slope fields is 7.3. Kind of a basic concept with some cool applications. We're just going to go through the video here at home. I apologize for having to do this lesson this way, but if we're going to do a lesson at home, this is the kind of lesson that you want it to be. So I'm just going to read through this paragraph really quick about slope fields. So what a slope field is, it's a graphical representation of a set of slopes that you get from a differential equation. Now remember, differential equations, they involve a derivative, right? So something like dy dx equals 7x. That's a differential equation. This one only has x's in it. Sometimes they have x and y's in them. In lesson, not 8.1, but 7.1, you learned how to solve differential equations by separating the variables. Now remember, this dy dx represents the slopes of a function. So when you are given a differential equation, you're given an equation that represents the slopes of the original function. Okay, and that's what a slope field is all about. It's about using the derivative equation to draw estimated slopes on the graph to kind of give a visual representation of what the general solution would look like. Okay, so even if you can't separate variables and integrate, you can still use the differential equation to plot the slopes and get an idea of what the function looks like. Okay, so when I look at this slope field, so I'm going to ignore all the numbers and stuff on the left. All I want to look at right now is this slope field. What these little dashes represent are the slopes of the function at that point. What we don't know is where the graph starts. We don't know if the graph is up here. We don't know if the graph is down here, if it goes through this point. All we have is a representation of what this function in general looks like based on the slopes at different points on the graph. So in example 1, it says find the slopes given by the differential equation dy dx equals negative x at the following points, or negative x over y at the following points. So it gives me this point, 3, 2, and it gives me the function, the derivative function. Well, that derivative function, dy dx, represents the slope of my function. And if I have this point, 3, 2, I can plug in those values for my x and for my y, and I can figure out what the slope is going to look like at that point. So my slope, dy dx, is going to look like negative x on top and 2 on the bottom. So I know that at the point 3, 2, my function would have a slope of negative 1.5. That's what the function would look like at that point. At negative 1, 3, my slope is going to equal negative 1 over 3, which is positive 1/3. So at negative 1/3, or at negative 1, 3, I have a slope of 1/3. At negative 2, 1, my slope is going to look like negative 2 over negative 1, which is positive 2 over negative 1, which is just negative 2. So at the point negative 2, negative 1, my function would have a slope of negative 2, and we go on and on and on, okay? So what we do is we use the derivative function to estimate what the graph is going to look like by plotting these little slopes and marking what that would look like on the graph. We can't, in this equation, we can't find the slopes when y equals 0 because y is on the bottom and we can't divide by 0. So unfortunately, we have no idea what the slope is doing at that point just because we're not allowed to do that. There is something happening there. We just don't know what. We can't mark that on our graph. So example 2 wants us to actually make this chart. So some of these points are already plotted for us. What we're going to do is we're going to go through, and we're not going to do all of them. You can do all of them at home. I'm going to show you some examples though. So a couple of key things about the slopes that have already been drawn. You notice all these little tick marks don't touch. Now, number one rule about making a slope field is not to let them touch. As soon as your slopes touch each other like this, now you get a 0 on the question, okay? You have to make sure all these little tick marks are separate. They've got to be short, simple tick marks that don't touch each other. Otherwise, you get in trouble. You don't get points on the question. So what it wants us to do is take the derivative, plug in these different points. So let's start with this one right here. So this point right here is -1, 1. So I'm going to plug those numbers into my derivative function. So I plug a -1 on top and I get a +1. I plug a 1 on the bottom and I get a +1. So my slope at that point is 1. So what I'm going to do is draw a little tick mark, just a short one that has a slope of about 1. Okay, they're not super picky on the test about your slopes, but you need to make sure they're relative to each other. Okay, or in other words, at -2, so at this point right here, let's do this one in blue. So at this point, that's -2, 1, my slope changes. I get a -2 on top, and it's already a negative, so that becomes +2, 1 on the bottom. So now I have a slope of 2. So when I draw this slope, I've already drawn this one. I just need to make sure that I'm steeper than that one, okay? It doesn't matter if my slope is perfect, as long as it is relative to the slopes around it. If I all of a sudden made that slope really flat, that is going to cause a problem, okay? But my slope is going to be +2, and we keep doing this. We do this for all these points that are on the graph. We'll do a couple more. So this one over here, that point is 3, 3. So when I plug that in, I get -3/3, which is -1. So I'm going to have a slope of -1 right there. So I make a little tick mark with that has a slope of -1. Let's do this one right here. So that point is 2, -1. So my slope, I plug in, I get -2 on top, -1 on the bottom. So my slope is going to be +2. So I just need to make sure that my slope is steeper than the ones that I've already drawn, okay? So that is a slope field. Now, right now, this just shows the general shape of the function, right? I don't know where my function is. If my function, it could go through here. It could go through out here. It just depends on a starting point. All I know right now is this is what the function would look like, but I don't know if my function is clear down here or out a little bit more or out a little bit more or out a little bit more. I don't know exactly where my function is located, but this gives me a general idea what it looks like. Okay, so in example 3, we've made the slope field. It wants me to start at 0, 1, and it wants me to follow the flow of the slopes to sketch the solution curve of 0, 1. So basically, if I had a point 0, 1, that's right. Why won't that draw for me? There we go. There's my point 0, 1. I want to draw a solution that goes through that point. All right, so right there, my solution has a slope of nothing, right? A slope of 0. And as I draw my line, I want to follow the tick marks. It's a safe general rule is that you shouldn't be crossing them. As you're drawing them, you don't want your function to be crossing over the tick marks. You're kind of trying to stay in between them to get the best visual of what your function would look like, all right? So this is what my function would look like going through the point 0, 1. Now, one of the biggest mistakes that happens on the test, right here, I don't know what's happening when y is equal to 0. So I've got to be really careful that I don't include that as part of my function. So I would put open circles there, because otherwise it's assuming that my function touches at that point, and I don't know what my function does because we have no idea what the slope looks like because we couldn't divide by 0. All right, so moving on. It wants me to, you can read through this on your own time. You can pause if you want to. Sketch a solution curve that passes through negative 1, 1. So this time I'm going to start at negative 1, 1, which is right. Ooh, that's not a good line. Is it purple better? Nope, purple's not better. All right, we're going to stick with red. So I'm going through negative 1, 1. So when I draw my solution curve, at that point, my solution should be following that line, and then I'm going to come down. Again, I'm going to have an open circle. And as I go up, I should be parallel to this curve that I already drew. In general, all of my curves, if I work my way out, my curves should all kind of follow the same pattern and be parallel to each other, right? They're going to go through different points, but they're going to have the same shape. These are all, semicircles? They have that same basic shape. 0, 3, it wants me to do one more. So negative 3. So 0, 1, 2, negative 3 is right there. So as I draw this one, I'm going to follow my curves, and I'm going to try not to cross too many places if I don't have to, and I'm going to put open circles right there. So yeah, semicircles look pretty safe. What type of graph does this differential equation seem to be producing? So my function that gave me this dy dx looks like it's probably like a semicircle or something like that. All right? Okay, again, the most common error, I brought this up already, is when you're sketching that you go beyond, you sketch too far. For example, if I had, if I had a slope field, and let's say that I had marked, these are my tick marks right here, right, that I'm going to follow. What happens a lot of time is it tells you, okay, so we're gonna graph a line through this point right here. So as you follow the tick marks, you can only go as far as the information gives you. If you keep going like this, you're gonna get it marked wrong because you don't know what's happening after that tick mark and after that tick mark. You've got to stop. And just like in this function, we don't know what's happening at 0, so we can't include that part of the graph. Even if it exists, we can't use the slope field to draw it because we don't know what it looks like. Okay, example 4. Now that we've kind of sketched what we think it looks like, it says to solve the differential equation. So this is an easy one. This is one that we can solve. I'm going to multiply dx to this side. I'm going to multiply y to this side. So I end up with y dy equals negative x dx. Now that my variables are separated, I can integrate both sides. So on the left-hand side, I get 1/2 y squared. On the right-hand side, I get negative 1/2 x squared plus some c value. We don't know what it is. We don't care, at least at this point, because it didn't give us starting positions. We just can leave it as c. So if we clean this up a little bit, I want to get the negative half to the other side. So I'm going to times both sides by 2. And that gives me, what? Y squared equals negative x squared plus c is still some constant. I don't know what it is, but it's some constant. It got multiplied by 2, and that's fine. It's still a constant. So at this point, to keep going, I've got to square root both sides. And when I do that, I get 2 different answers. So when I square root this side and square root this side, I get a positive answer and a negative answer. So y is going to equal the square root of negative x squared plus c, and it's also going to equal the negative square root of negative x squared plus c. And depending on what part of the graph I'm using, I might use the negative or the positive version. It just depends on the points that I'm working with. So this tells me to find the particular solution when the graph passes through 0, 1. So I want to take 0, 1, I want to plug it into one of these to get the appropriate answer. So y is going to be 1, and that's going to equal, I know I've got the square root of negative 0 squared plus c. Now I've got to decide, is it going to be a plus or a minus? Well, when I look on the left-hand side, I have a positive number. So the right-hand side should be a positive number, which means I want to get rid of that negative. So I'm going to use the positive version of this equation. 0 squared is 0. Negative 0 doesn't exist, right? It's just still 0. So 1 equals the square root of c. To solve for c, I square both sides. So 1 squared equals c. 1 squared is just 1. So my c value for this one, for this particular solution, my c value is 1. So I would say that y equals the positive square root of negative x squared plus 1. That's my solution. Okay. You know, we kind of skipped over something that I realized we didn't bring up. Right here, I kind of went through it really fast. If I rewrite this equation to be y squared plus x squared equals c, that's the equation of a circle. And when I look at our slope field, that looks like my function is going to be a circle. So my function, my slope field matches my function. So I probably did it correctly. I can kind of use that information to check my work and see how good my estimate was. Now it wants me to find the solution when I go through 0, negative 3. So negative 3 is my y value. And again, I have to decide plus or minus square root negative 0 squared plus c. Now in this case, I've got a negative number on the left. So when I pick my plus or my minus, I want it to be the minus because I want it to match what's on the left-hand side. So negative 3 equals negative square root, which is nice because the negatives drop. So I just get 3 equals square root of 0 plus c. Square both sides, 9 equals c. So in this case, my solution would be y equals the negative square root of negative x squared plus 9. Okay, example number 5 gives me a new field to fill out, and it tells me the differential equation y prime equals 1 over y. Draw the slope field in the dot coordinate plane at the right. All right, so here's my slope formula. dy, excuse me, dy dx equals 1 over y. And I love it when this happens because notice that there's no x's. So when I plug in numbers, my x value doesn't matter. The only number that matters is my y value. So for example, let's start with, I can't plug in anything with a 0. So my 0 line is off limits because the bottom of my function can't be 0. So let's plug in this point right here, 1, 1. So when I plug in x equals 1, y equals 1, I just end up with 1 over y, which is 1. So that is 1. So my slope right here is going to be a 1. But notice, now let's do 2. The point 2 comma 1, I'm going to plug in to 1 over y. So this time I'm going to get 1 over 1 again. It doesn't matter that my x changed because there's no x in my function. So my slope is still 1. So when there's no x's, the only number that is affecting my slope is the y value. So along this line, all of my slopes are going to be 1. So let's move up to 2. So let's start trying, let's do this point right here. So 1 comma 2, when I plug that in, I get 1/2. So my slope gets a little bit flatter. And it doesn't matter as I move to the left or the right because there's no x value going in. So 2, 2 is also going to be a half. 2 or 3, 2 is also going to be a half. So all of these slopes are halves. And again, those didn't match very good, did they? I didn't do a very good job making those all, come on, look the same. So let's try do a little bit better of a job making them look like a half. All right, little bit better. Close enough. And they're not touching. That's the other important part, right? So now let's try 1, 3. When I plug that in, I get 1/3. So my point 1, 3, my slope's even flatter than it was before. And that's going to be the same all the way across. There's no x value, so my slope stays the same. So now let's go down. Let's try 1, -1. So when I plug that in, I get 1/-1, which gives me -1. So below, at this point, I have a slope of -1. And again, as I go to the right and left, that slope is going to stay exactly the same because there's no x to change it. So now let's plug in 1, -2. And that gives me 1/-2, which gives me -1/2. So my slope is still negative, but this time it's a little bit flatter, right? All the way across. When I plug in 1, -3, I'm going to get a slope of -1/3. I'm seeing a pattern here. I hope you are too. And there's my slope field, okay? So on the test, make sure they don't touch. And make sure they're relative to each other, okay? Again, they're not going to get out a measuring tape and measure if it's exactly a slope of a half. They're not looking that closely. They're looking at the general shape. So make sure you're doing a pretty good job there and you'll be just fine. So now that's part A, got my slope field drawn. Graph the particular solution through the points -2, -1. So it wants me to start at -1, -2, -1. So it wants me to start right there. I'm trying not to cover, we'll do black. So -1, -2, it wants me to start right here, and it wants me to graph my function. So as I go to the right, I'm going to try to follow this line without crossing too much. I went a little bit too flat, didn't I? I should be going like this. There we go. I got too flat too early. Now going this direction, I know what's happening until I get to that point. So I'm going to put an open circle right there because I don't know what my function is doing at that specific point. It's doing something, I just don't know what it is. 2, 2. So now if I go over 1, 2 and up 2, this one, same idea. I'm going to follow my slope field. That was not a good follow. We probably need to go below this one. So I'm going to come up and then I'm going to start to flatten out, right? I probably went farther than I should. Let's do that same thing, but let's stop right there where our slope field stops and put the open circle right there, okay? I don't know what's happening over here, so I really shouldn't assume that this keeps going. I want to stop right there in the bounds, kind of like I did right here. I want to stop in the bounds of my slope field. Okay, step 3, solve the differential equation. So dy dx equals 1/y. So I multiply dx over, I multiply y over. So y dy equals 1 dx. When I take the integral of both sides, we've been doing this so much, I'm going a little bit fast. 1/2 y squared equals x plus c. Times everything by 2, so y squared equals 2x plus c. And then again, plus or minus the square root. So y equals plus or minus the square root of 2x plus c. That's my general, whoa, what happened? That's my general solution, okay? Now it wants me to write a particular solution when I go through -2, -1. So my y value is -1. I'm going to have to pick plus or minus, but my x value is -2. So 2 times -2 plus c. Now I already know the outside Because the left side is a negative, I want the negative version of this question, which is nice because the negatives go away. 1 equals square root of -4 plus c. Square both sides, 1 equals -4 plus c. So c equals 5. So in this case, at -2, -1, my function, the particular solution would be y equals negative square root of 2x plus 5. Now at 2, 2, I plug those in. So 2 equals plus or minus the square root of 2 times 2 plus c. The left side is positive, so I'm going to use the positive version of this equation. So 2 equals the square root of 4 plus c. Square both sides, 4 equals 4 plus c. And that means c is going to equal 0. So my particular solution for this one is y equals the positive square root of 2x. The c value is nothing. It's a 0 for that one. Okay, example 6 and 7. The AP test loves these ones, and we're going to practice these in class a little bit when you come back. Which of the differential equations matches the slope field to the right? So it gives you a slope field filled out already, and it wants you to pick which ones match. So first thing I always look for is there a pattern going left to right or up and down? Okay, so when I look at this function, as I move up, my slopes change. So that tells me that there is a y in my function because it changes as I go up. As I move to the left and the right, my slope stays the same the entire time, which tells me that there is not an x in the function. So when I look at these list of options, that's not even an option. That's not an option. I can eliminate 3 of them just because I can look at the graph and tell that the x doesn't change my slope. So now I'm left to picking between these 2. The next thing I like to do is pick a point and plug it in. So for example, this one right here, that point is 0, 0. So if I plug that into this one, my slope for that function is 0. If I plug it into this one, my slope is 1 plus 0, which equals 1. Well, when I look at the graph, it shows me what the slope should be, and the slope is definitely not 0. It looks like it's more 1. So this function is not correct. It's not that one. It's going to be D, would be my answer. So you use the graphs that it gives you and the slopes on that graph to try to figure out which function is even possible, okay? Example 7 is a little bit different because in example 7, it gives us the slope field and it wants us to pick which actual function could match this slope field. In this one, I still think it's easier. I think it's easier to find the derivative and compare the slopes. So for A, instead of y equals y x, y prime equals e to the x, right? For B, y prime is going to equal negative e to the negative x. For C, y is going to equal negative e to the x. For D, y is going to equal negative 1, y prime is going to equal, both of those are y primes. Y prime is going to equal negative 1 over x, and for E, y prime is going to equal positive 1 over x. Okay, so when I look at all of these slopes, 3 of them have an e to the x, and 2 of them are fractions with an x on the bottom, which means that x can't be 0. But when I look at my slope field, x being 0 is marked right there. So I can eliminate these 2 because it's okay for me to plug in x equals 0. That doesn't give me an issue. Now I've got to decide which of these other functions work. Now, I can eliminate e to the x because I know that e to the x doesn't look like this, right? My function looks like that right now, and that's not what e to the x looks like. So I have to determine which one of these is the correct one. And I'm gonna plug in a couple of different numbers to do that. One thing that I notice is as my function moves to the right, look at what my slopes do. My slopes are really steep on the left-hand side, but as I move to the right, my slopes get flat. So one of these functions is going to get flatter as it moves to the right, as my numbers get big. So let's pick something. Let's pick like x equals 4, and let's see which one of these function gives me a flatter slope. So the first one, y prime, is going to equal negative e to the negative 4. I don't have my calculator, so I don't know what that number is. I know it's a negative number. But the e to the negative 4, I can move to the bottom and call it e to the 4. So that tells me I have a negative slope, and the bottom is getting really big. The bottom value is getting really big, and the top value is staying -1. And if I think about what that means, what happens when I have a number on top and something getting really big on the bottom, that is what happens when you approach 0, which means you're getting flat. Because my slope is getting closer and closer to 0, so it's getting flatter. So I don't even have to try the other equation. I think that the correct answer is B. I think it's this one right here. If I plug in that same value, if I plug in 4 to this one, y prime equals negative e to the 4th. So I have a negative slope, but e to the 4th is a big number. When I look at this graph, e to the 4th is not a big slope. It's a really flat slope. So this one is not correct. I feel pretty good about B, okay? So using 7.1, where we solved differential equations, and then using 7.3, where we showed graphically what the solution looks like, you can use those two aspects to confirm solutions for differential equations. You can use those to figure out where the function, which of the functions is the correct one, and like which function matches the slope field. You get to use a little bit of 7.1 and 7.3. So on the homework, if we can get to it, there we go. On the homework, you're probably okay. A tear-out sheet is provided on page 181. I did not provide you a tear-out sheet. I'm guessing the tear-out sheet is a bunch of slope field blanks like this that just have points for you to fill out. So I'll try and find that, and I'll post it with this video so you can print it, or you can just make your own at home, or you can find your own slope field graph online and you can print it that way. So go ahead and go through 7.3. Email me if you have any questions, and we'll see you next week.